Hello everyone. In this video we're going to go ahead and enter chapter 3, and we're going to start chapter 3 by discussing the radian measure of angles, which is a measure we have hinted at before and we will now formally introduce. We'll be looking at the radian measure of angles, conversions between degree and radian measures, and also trigonometric function values of angles in radian mode. Imagine sweeping. Keep your focus on this red angle here. You start with your initial side on the positive x-axis, and you basically sweep an angle in such a way that the length of the arc here is exactly the same as the radius of the circle. And if you do so, you have basically spanned an angle which is exactly 1 radian. So this is how we define the radian measure of an angle. Notice that it is directly related to the radius, therefore the name radian. Now, what if you don't stop there, right? What if you go another radius worth of distance there? Then you basically are going to create an angle which is measuring 2 radians. So if I were to draw that, it would look something like this. Okay, I'm going to try that again, try to do a better job. So we'll be looking at angle about that much. So notice that now you're looking at angle looking like that, and it has swept through basically 2 radii, and so therefore this angle here will have a measure of 2 radians instead of 1 radian. So if you sweep enough so that you cover an arc with the length of 1 radius, the angle you create has a measure of 1 radian. If you go through 2 radii, you'll get an angle whose measure is 2 radians. If you do it with 3 radii, you'll get an angle whose measure is 3 radians, such as shown with the green here. And as it turns out, if you go all the way to the point which we normally consider to be half a circle or 180 degrees, that's going to be just slightly over 3 radians. How much? Exactly pi radians. Okay, you know the number pi, 3.14, etc. So if you start here and go 1, 2, 3, and then enough to where you get to the number pi, then you have gone through exactly pi radians. So in other words, pi radians is exactly the same as 180 degrees. Okay, they're equivalent measurements for the same angle. All right, and in fact this is what's going to give us what we need to convert between the two measurement units. We'll look at that next. In other words, conversions between degree and radian measures. So as we just mentioned, pi radians is exactly 180 degrees. So we're either going to multiply by pi over 180 degrees or 180 degrees over pi. These are called unit factors because notice the top and the bottom represent the same quantity, so therefore they can be canceled out, leaving us 1. So that's why we call them unit factors. Now you multiply by this unit factor if you want to go from degrees to radians, and you multiply by that one if you want to go from radians to degrees. Here's an example. Let's say you want to convert 50 degrees to radians. So what you do is you go ahead and multiply by pi over 180 degrees. Notice this makes sense because now the degrees will cancel the degrees here, and you end up with 50 degree pi over 180 degree. I still have the degrees there, but they will cancel out. Notice they're gone now. So 5 pi over 18. So what's the unit? What do you write? Well, you could write radians, right? But we don't need to. In other words, radian measures are basically a measure of counting radii, right? So we don't need to write anything. So when you see an angle measure and it has no units written next to it, you automatically assume that it is in radians. That's why it is so important that if you are dealing with angles and you want them to be in degrees, you have to put the degree symbol, because if you don't put the degree symbol, it's going to be assumed that the angle is being given in radians. So now let's go the other way. Let's take 5 pi over 6, which is a radian measure, and convert it to degrees. So what we do is we multiply 180 degrees over pi. This time the pi's will cancel out, and when you multiply that out, 6 into 180 is 30 times 5 is 150. So you get 150 degrees. This time there's only one degree term, so it's not going to cancel out as you would expect it not to, because you are indeed going into degree mode. And that's how you do these conversions. Let's go ahead and practice a bit. Notice that 0 degrees, you would want to multiply, if you want to convert it to radians, you'd want to multiply by pi over 180 degrees. Now, of course, 0 times pi is just 0 divided by 180 is still 0, so you get 0. So 0 degrees and 0 radians represent the same angle, right? 45 degrees, we go ahead and multiply by pi over 180 degrees, and this time the degrees will cancel out. 45 goes into itself once, into 180 4 times. So notice we get pi over 4. Again, you don't need to write radians after it. Even though you know it's in radian measure, not writing anything indicates radian measure. All right, so negative 120 degrees times pi over 180 degrees. And this time the zeros definitely cancel out, the degrees cancel out, and 6 goes into 12 2 times, and 6 goes into 18 3 times. So we end up with negative 2 pi over 3. So this represents exactly negative 120 degrees, or so this is in radians. All right, 46 degrees 50 minutes, we want to convert that to radians. So what we're going to do is we're going to first convert it into pure degree mode. So we get 46 degrees plus 50 over 60 degrees. So we get basically 46 and 5/6 of a degree. 50 over 60 is the same as 5/6, right? So notice that I can go ahead and convert that into a proper fraction by actually I'm an improper fraction because the numerator will be higher than the denominator. So we get 6 times 46 plus 5, 281 over 6 degrees, correct? So 6 times 46 plus 5. Okay, now all we need to do is multiply by pi over 180 degrees, and we'll get ourselves the answer in a radian mode. So we get 281 pi over 6 times 180. There we have it. Now, if we could reduce these, we would, but they don't have a common factor, so we are basically done. So we just converted this angle into radian measure. All right, let's go ahead and convert a few angle measures that are given in radians to degree measure now. So remember, for that, we're going to take the angle and multiply it by 180 degrees over pi. Because remember, you have 1 radian here and radian here, those would cancel out, so we would end up with something in degrees, right? So now what we're going to do is we're just going to calculate 180 divided by, let's see, divided by pi. So we get approximately 57 degrees. Let's just round it to the nearest whole number, right? So 57 degrees. Notice that's going to be almost 57 degrees. So you see why we keep emphasizing the fact that you have to make sure that you're in the correct mode, because remember, 1 radian has nothing to do with 1 degree, right? They're very different. 1 radian is in fact almost 57 degrees, right? Close to 60 degrees. So that's why if you were to type in a number that is in radian mode and you meant a degree mode, you're going to be so badly off that the answer won't make any sense. All right, so now let's take 9 pi over 4 and convert it to degrees. So what we're going to do is we're going to multiply by 180 over pi. When there is a pi in the original number, they will cancel out, and so we just get 9 times 180 degrees over 4. So 9 times 180 divided by 4. So we get 405 degrees. All right. So negative 5 pi over 6. Again, if you get the drift of it, then definitely try them on your own without watching what we're doing. That's your best bet. So the pi's will cancel out. Notice 6 and 180 will leave you 30 up here. And now we just get negative 150 degrees, like that. All right, so 4.25 times 180 degrees over pi. And now we just go ahead and multiply that out. So we have 4.25 times 180, and then we're going to divide by pi. So we end up with approximately 244 degrees. All right, so you can see just how different radian and degree measures are, right? You have to be very careful, but there is a nice conversion where you can go from one type of unit to the other. Here's a nice visual of some of the special angles we've been dealing with using both notations. So notice here we have a 30-degree angle which corresponds to pi over 6, right? Now there is a nice shortcut. Remember, we know that if we want to go from radian measure such as this to degree, we need to multiply by 180 over pi, right? But notice what happens, the pi, when there is a pi in the original radian measure, right? Notice that that will always cancel that, and you end up just dividing 180 by that 6, for instance, right? So the shortcut is this: if there is a pi in the original radian measure, then just replace it with 180 degrees and you'll get the degree measure very quickly, okay? So notice like this will give you 30 degrees. Pi over 4, so remember, if you use that shortcut that I just showed you, you want to convert pi over 4 to degrees, just replace pi with 180. So you get 180 divided by 4. You won't be able to do that if there is no pi in the radian measure, right? The way that it's stated. But when there is a pi, the fastest way is just to replace the pi with 180 degrees. So notice that gives you 45. Now remember, pi over 3, just replace pi with 180 degrees, you get 180 divided by 3, so 60 degrees, okay? Pi over 2, of course, 180 degrees divided by 2, that's 90 degrees. 2 pi over 3, okay? So it's nice to be able to come up, you know, to get so comfortable with a radian measure that you don't have to always convert. So for example, I know that I can jump in sixths of a pi increments, and I have 1 pi over 6, 2 pi over 6. Notice 2 pi over 6 is the same as pi over 3, see? And then so that's 1/6, 2/6, 3/6. Notice 3 pi over 6 is the same as pi over 2. And then the next one will be 4 pi over 6. Once again, notice 4 pi over 6, 2 and 3, that's the same as 2 pi over 3. Notice I don't have to sit there and convert. And then the next one will be, I know this was 4 pi over 6, so this will be 5 pi over 6, 6 pi over 6. Notice 6 pi over 6 is just pi. Then 7 pi over 6, then 8 pi over 6, which is, of course, if you simplify it, 2 goes into 8 4 times, into 6 3 times, so that's 4 pi over 3. So 8 pi over 6, 9 pi over 6. 3 goes into 9 3 times, into 6 2 times, so that's 3 pi over 2. And then 10 pi over 6. Notice 10 pi over 6. 2 goes into 10 5 times, into 6 3 times. That's the same as pi over 3. And then 11 pi over 6. 10 pi over 6, what's next? 11 pi over 6. or you can jump in increments of pi over 3, right? So that's 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3. What is 6 pi over 3? That's 2 pi. So that's 2 times 180 degrees. So it's what? 360 degrees. You want to get really, really comfortable with this chart, you know, or this graphic and these special angle measures, right? And you should be able to do, you know, be so comfortable with radian measure that you don't have to always do conversions. If you do conversions, that's no problem, but I'm saying you shouldn't always have it. Now there is a group we ignored. Those are quarter jumps, right? So what if I start here, I jump, that's pi over 4, and then the next one will be 2 pi over 4. Notice 2 pi over 4 is the same as pi over 2. Next I get 3 pi over 4 over here, and then 4 pi over 4. Of course 4 pi over 4 is, these cancel out, just pi. And then 5 pi over 4, 6 pi over 4. Notice 6 pi over 4, 2 goes into 6 3 times, into 4 2 times. That's the same as 3 pi over 2. And then 7 pi over 4, and then 8 pi over 4. 8 pi over 4 is just 2 pi, see? Which is again the same as 360 degrees. So become really familiar with this scenario, because this, we're going to be using this kind of a setup very heavily from this point forward. Now we want to evaluate some trig function expressions which are given to us in radian mode. Until we become really comfortable with radians, we will go ahead and do some conversions. Notice that 2 pi over 3, rather than become comfortable until we actually come up with this really helpful entity called the unit circle, from that point forward we'll be able to work directly with radian measures. Until then we can go ahead and do some conversions. So that's 2 times, remember, just replace pi with 180. That's the quick conversion of radian to degree mode when the original radian measure has a pi in it, right? Otherwise you just multiply by if you want to go from radian to degree, you just multiply by 180 over pi, okay? So but when there's a pi, simply just replace it with 180 degrees and you'll quickly get your degree measure. So 3 goes into 180 60 times, so you get 120 degrees. So basically here it's the same thing as the tangent of 120 degrees. Now if we do a quick sketch, we know that 120 degrees, now from here that's 90 degrees, so 120 is 30 more than that, right? So here we have so this angle right here is 30, which makes this one 60. So again, this one here will be 30. So that means this is going to be 1, which means this location here is -1, and the radius will be 2, which will be the hypotenuse of that triangle, and the side opposite 60 will be square root of 3, right? So the point here will be -1 and positive square root of 3. Tangent is of course y over x, so it's going to be square root of 3 over -1, so it'll be negative square root of 3. So this is exactly what we did in our previous video, right? All right, so that's that for tangent of 2 pi over 3. All right, so next we have sine of 3 pi over 2. Now if we do a quick conversion, we have 3 times all right, let's see if this will cooperate. So we have 3 times 180 degrees over 2. Notice that 2 goes into 180 90 times, right? So basically we're looking at a 270 degree angle. So basically that becomes sine of 270 degrees. Now if you quickly sketch the situation, notice starting here we go, that's 90, 180, 270 right there. So we're dealing with an angle with a terminal side which is negative y-axis. So if I pick a point on that terminal side, it could be something like 0, -1, right? So this is x, that's y. We know sine is the y value divided by r. Now remember here, since this is the point 0, -1, that means this is -1 and that distance will be 1. So r is 1. So we get -1 over 1, which is -1. Okay, so you see it's very easy. Once you convert it, you know how to do degrees already. So that's that. So for -5 pi over 3, the next one, so -5 times 180 degrees over 3, we're using our little quick method when there's a pi available. And here 3 goes into 180 60 times, so we end up with -5 times 60, which is -300 degrees. All right, so basically we're finding this is like finding the cosine of 300 degrees, right? So let's take a look at a visual here. So remember, -300 degrees, so we're going in this direction clockwise. So that's -90, -180, -270, and keep going 30 more, and that'll be negative. So that'll be -300 degrees, right? So if I make my right triangle, remember this was 30, right? So that makes this 60, which makes that 30, which means of course the opposite 30 is 1. Then the opposite 60 will be square root of 3, and the radius will be 2, or the r value, right? You can see why we call it r, because it will be a radius of a circle, as we will soon find out. So we're looking for the cosine. The point here is 1 comma square root of 3, right? And cosine is x over r. So it's going to be 1 over 2. That's it. You could have, of course, just looked at that 1 and that 2 as well, but we're being consistent with our approach, so we did it that way. All right. Okay, next we want to compute the cotangent of -15 pi over 4, which we can quickly convert. So -15 pi over 4, so -15 times 180 degrees over 4. I know 4 goes into 180 45 times. So basically we have 15 times 45. That's going to be 675. So we get negative 675 degrees. Now remember, we're going to want to find a reference angle for that. So first thing we'll do is we'll go ahead and take that and divide it by 360 to see how many 360s will fit there. And so basically more than one, almost 2. So what we will do now, since it's a negative angle, we'll go ahead and add 2 times 360 to it. So we see it's going to be coterminal with a 45-degree angle. So this is just going to be the same as the cotangent of 45 degrees. Now for 45 degrees, of course, we can just use our 45, 45, 90 triangle. It's very easy, right? And SOHCAHTOA. So we have 1, 1, square root of 2, 45, 45. So just take this 45-degree angle. Cotangent is adjacent over opposite, right? So it'll be 1 over 1, which is 1. There you have it. Those are, evaluations of expressions where the angle is in radian measure. All right, so this is probably one of our shortest lessons, and we're going to basically wrap it up with this nice problem. Through how many radians will the hour hand of a clock rotate in 22 hours? Remember that a clock basically takes a circle and breaks it up into 12 equal sectors, right? So each of those sectors, notice, will have 360 degrees divided by 12, which is 30 degrees in it, right? So each one of those will be 30 degrees. Now 30 degrees, of course, as you know, can be quickly converted to radians if we multiply by pi over 180. 30 and 180 will leave us 6, so we get pi over 6. In other words, in 1 hour, the hour hand of a clock will rotate through pi over 6 radians, right? So you want to know how many it'll sweep through in 22 hours? Easily. I mean, that can easily be found by just taking 22 and multiplying it by pi over 6. So notice that we can cross cancel 11 and 3. So basically the hour hand of the clock will sweep through that many radians in 22 hours. There is one subtle point that I want you to be aware of, because remember we said that for a clock we take a circle and break it into 12 congruent parts, each measuring 30 degrees or pi over 6 radians. I do want you to note the fact that even though we use that language, it's not really the circle that's being broken into these sectors, it's the disk that is enclosed by that circle which is being broken into those equal sectors. So Uh, be careful to understand the distinction between a circle, which is just the ring itself, right? And the disk contained within that circle. Otherwise, we would have called those disks that you have, which you have music on, we would have called them compact circles, but we don't, right? We correctly call them compact disks. All right, just a little technicality, and that's all I wanted to say about that. Which goes, of course, for the area of a circle as well, right? When we say find the area of a circle, we don't really mean find the area of the circle, because the circle is just that ring. We mean find the area of the disk enclosed by that circle. So as long as you know what we mean, we can continue to speak in a way which may not be 100% correct, but we understand each other. All right, so that should wrap it up for us for today. Again, a very nice short lesson. I'm sure you'll find it to be a nice break from some of our longer lessons. And please get the homework done on time, and I will see you at our next video.